today I'm going to explain about Colosseum. The Colosseum is a great example of how geometry helped ancient Roman architects build amazing structures. Its shape is based on an ellipse. A curve from that makes it easy for everyone in the audience to see and hear the action in the center. This elliptical design also makes the building balanced and strong. The Colosseum uses many arches and vaults, which are curved shapes that spreads out the weight of the building so it doesn't collapse. These arches appear again and again in a regular pattern around the walls, showing that the Romans understood repetition, symmetry, and proportion. Inside, there are many radial and circular walls. This kind of layout divides the seating areas clearly and help people find their ways to the seats quickly. The hallways and stairways follow a radial pattern that guides crowds smoothly into the stand. Overall, the Colosseum shows how Romans used geometry not just to make things look beautiful, but also to solve practical problems like strength, space, and crowd movement. It reflects the advanced skill in math and engineering.
For this slide, I'm estimating the volume of the Colosseum by modeling it as an elliptical cylinder. The major axis is 189 meters and the minor axis is 156 meters. So the semi-axis are 94.5 meters and 78 meters. Using the formula A equals to pi mb, I find the area of the elliptical base, which is about 23,150 square meters. When I multiply this by the height of 48 meters, the volume comes to roughly 1.1 million cubic meters. This slide is about angles of elevation and depression. The angle of elevation is when you look up at an object, and the angle of depression is when you look down from the horizontal. Using basic trigonometry, I calculate both angles and they turn out to be the same at about 49.82 degrees. This shows how trigonometry can be used to solve real-life problems involving height and distance.
So, in this slide, I will explain how the number of seating chairs in the Colosseum was calculated. The total height of the Colosseum is approximately 48 meters. However, only about 30 meters of this height is allocated to the seating area. Each seating tier has an average vertical rise of 0.4 meters. To determine the number of seating tiers, the total seating height is divided by the vertical rise per tier. Therefore, 30 divided by 0.4 results in 75 seating tiers. These calculations provides an estimate of how many rows of seats could be constructed vertically within the Colosseum. This slide focuses on the calculation of the angle of elevation, which is essential to ensure clear visibility for spectators. The angle of elevation is calculated using a trigonometric relationship, which is tan theta equals to vertical rise divided by horizontal distance. In this case, the vertical rise per tier is 0.4 meters, while the horizontal distance to the arena is 1.2 meters. Thus, tan theta equals to 0.4 divided by 1.2 meters. By calculating the inverse tangent, the angle of elevation is approximately 18.4 degrees. This angle ensures that each successive tier is positioned higher than the previous one, preventing visual obstruction and allowing spectators to view the arena clearly. Lastly, this slide presents the estimation of the Colosseum seating capacity. The average weight required per spectator is approximately 0.5 meters, and the estimated perimeter of the ellipse is 550 meters. Dividing the perimeter by the weight per person gives approximately 1,100 seats per row. With a total of 75 seating tiers, the estimated seating capacity is 82,500 seats. However, not all rows are fully occupied due to the presence of the stairways and the aisles. After accounting for the structural features, the final estimated seating capacity is approximately 50,000 to 65,000 spectators, which aligns with historical records of the Colosseum's capacity.
For the second topic, we're going to discuss about Rubik's Cube. The Rubik's Cube is a well-known puzzle used by people around the world. It has 6 color sides and was invented by Erno Rubik. Solving the Rubik's Cube help improve thinking skill and problem-solving ability. Today, the Rubik's Cube is also popular in competition where participants compete to solve the cube in the shortest time. In conclusion, the Rubik's Cube is more than just a game. It is an educational puzzle and a competitive activity that develops focus, speed, and patience. Because of these benefits, the Rubik's Cube remains popular among students and adults. Let us go to calculation of the Rubik's Cube. As we know, Rubik's Cube is a cube prism. So, the value of all sides is same. The value of one side is 6 cm. That means the length, width, and height is 6 cm. How to calculate the volume of cubic? The volume formula is length multiply width multiply height. So, 6 multiply 6 multiply 6 equal to 216 cube. How to calculate the area of cubic? The area of cubic formula is length multiply width. So, 6 multiply 6 equal to 36 centimeter square. And the last one, surface area. We can calculate the surface area by imagining the cubic is unfold. So, we can see the Rubik Cube have 6 faces. So, the easier formula is face multiply area. So, 6 multiply 6 multiply 6 equal to 216 centimeter square. That's all from us. You can ask any question in the comment. Thank you.